Everyone, we're on the third of our three macromolecules, so that's proteins. Proteins are a little bit different actually because in the case of carbohydrates and lipids, those are used primarily for energy. So the majority of carbohydrates and the majority of lipids are used for energy. It's not that lipids can't be made into other things. For example, the cholesterol is made into hormones, right? So lipids can do other things other than be made for energy. But the vast majority of lipids and carbohydrates are used for energy. With proteins, it's the opposite. The vast majority of proteins, about 90% of proteins, are not used for energy, but are used to make different things in our body. And these are some examples here. We tend to think that proteins are hair. We might know that hair is made out of proteins and muscle, but really it makes everything, right? So even if you look at your bones, the foundation of your bones is collagen. Those are proteins. Um, the pigment in my hair or the lack of pigment in my hair, that's proteins. The shape of my hair is proteins. It's not just that the hair itself is protein. So proteins really do everything in your body. Where do we get them from? Food, um, meat, muscle. So poultry, um, fish, it's all muscle. And then egg whites, which are considered the perfect protein. And then beans and nuts, seeds, things like that. Peas, that's what I was thinking of. So I look at proteins as like a chain, and the chain is made from links. And there's 20 different kinds of links. So imagine there's like 20 different colors of links, and you just take these links and you put them together and you make different lengths of chains. That's what proteins are. And the links are amino acids. So there's 20 different amino acids. You don't have to know the layout of them. I just put it on there. So there's two things that are important about proteins. And actually, the first thing is probably the most important. So the first thing is going to lead to the second thing. The sequence or the order of amino acids has to be exact. So if we were to ask, why are you uniquely you? Why are you tall or short? Why is your skin light or dark? Why are you going to get diabetes? You would say, oh, that's all written in my genes. It's all in my DNA. Well, that's true. But your DNA codes, it's the code for the order of amino acids in your body. You are who you are because of proteins. The protein is what it is because of the order of amino acids. That order is what's written. That's the DNA code. So I'm giving you an example here with sickle cell anemia. That's like the quintessential example of what happens when you get one amino acid wrong. So the amino acid that codes for the shape of red blood cells is around 500, I don't know what it is exactly, 535, about 500 amino acids long. Only one of those amino acids, number 6, is different. That was enough to change the entire shape of your red blood cell. So the implication of that is they don't carry oxygen around as well. And there's other things. They tend to clog capillaries. So the point is the sequence was off by just one. The sequence of amino acids actually contributes to the shape of the protein. So number 2 here, the shape of the protein, is actually covered by number 1. So there's 20 amino acids. 9 of them are essential. So if you remember, what does essential mean? It means your body needs it and it cannot make it on its own. So you have to get it from food. So 11 are non-essential. If you don't get them for a while, you're not going to die, right? But 9 of them are essential. So it's not just a protein. When you think about the food you eat, it's not about just the fact that, oh, that's high in proteins. Does it have all the essential amino acids? And are they absorbable? So out of those 9, there's 4 that are we call them limiting amino acids because they really are used a lot. We use them a lot. And it's methionine, lysine, threonine, and tryptophan. You've probably heard of tryptophan before. So as I was about to say, proteins, it's not that they're just in food, they have to be bioavailable, meaning that they have to be easily digested, because not all proteins are digested in our food. When you eat a steak, that's not all getting broken down into proteins that are going to be absorbed and used by our body. So some protein sources are better than others. Meat is a good one. But if you look at the score right here, this corrected score, egg whites are at the top. So egg whites are the perfect protein. It's the protein by which we judge all other proteins. There's also casein protein, like the protein that's in breast milk or other milk. Right. So if you look at the top, what has a score of 100, you have like fish, meat, eggs. They are considered like complete proteins. They have all the amino acids that we need, all 9, and they're pretty easily digestible. So if you go down a little bit, down to peanuts, because we often think, oh, peanut butter, that's a good source of energy. And there's a lot of protein bars that are like peanuts, right? It's probably whey that's giving you the protein. But if it's something like, I don't know what those protein bars are called with just peanuts. Well, yeah, it's protein, but it's not the right protein by itself. It doesn't have all the essential amino acids. So just peanuts or peanut butter would be considered an incomplete protein. It is a protein, but it doesn't have everything we need. So what we do often is that we combine incomplete proteins to make a complete protein. And I gave you an example, a couple examples down here. Peanut butter and jelly. The peanut butter is incomplete, but there is some protein in bread. Not a lot. Bread's a carbohydrate, right? But there is some protein in everything. There's protein in lettuce, right? There's just not a lot. So, but the protein that happens to be in the bread complements the protein it has what the peanut butter is missing. Same things can be said of red beans and rice, or corn and black beans. Right? What's missing in the beans is covered by like the rice or the corn or the bread. So those are complementary proteins, putting incomplete proteins together. What are examples of complete proteins? Egg whites, meat, milk products. Like milk is not primarily protein, but the protein that's in milk is complete. So milk products, meat, eggs. Trying to think if there's anything else that shoots out at me. Not at the moment. Did I say fish? Fish. Okay. These are 2 examples of when we don't get enough protein. And in this country, we actually do get enough protein, almost everybody. And the exception to that is alcoholics. So in that case, we're talking about marasmus. And you might see marasmus in this country, but you're not going to really see kwashiorkor. That's really for some other countries. And you do not have to memorize all of this. Just kind of keep it in your head that marasmus, sometimes you'll see that in alcoholics because they get a lot of their energy from alcohol. So they don't eat a lot of proteins. You might see them with like skinny bones, but like a big stomach. And it's not like a regular stomach. The big stomach's up here at the liver. It's a fatty liver. So if you look at the bottom of the list, you'll see like fatty infiltration of the liver, right? So if you ever see like commercials where there's like really poor kids, you might see that they have big stomachs. That's actually their liver. So what's the RDF protein? The recommended dietary allowance. How much should we have? It's weight-based. And in all the sciences, nutrition being one of them, we use the metric system. So you have to convert your weight to kilograms. The easiest way to do that is, in my opinion, is to take your weight and multiply it by 0.45. So 150 pounds times 0.45, that's going to give you like 68 kilograms, right? So you're around there, around 50, 60, 70, 80 kilograms. Right? So take your weight, multiply by 0.45, right? Then we're going to take that number. I wonder if I can pause this because my battery is like almost dead. We're going to take that number. I'm stalling here while I get my not recording anymore. Oh, there it is. Okay. I'm going to stay in the call and I'm going to see if I can pause this. Stop recording. All right. I'm actually going to hold on and try to get my charger. I'm still going to pull this off. Look at that. You didn't even know I was gone. All right. Back. So get your weight in kilograms, multiply that by 0.8. That's going to give you how many grams of protein you need a day. So it's weight based. Now, there's people that need more than 0.8 kilograms or 0.8 grams per kilogram. That would be people in hospitals. So people on TPNs, like some kind of like anyone on parental nutrition or anyone on a peg tube or whatever, they're going to need more because they're trying to heal. People that are trying to heal need more proteins. Proteins make everything in us. So if you're trying to heal, you're trying to recover from anything, you're going to need more proteins. People that are trying to bodybuild, they're going to need more proteins. Right? So you're going to go with higher than, there's cases where you're going to go higher than 0.8 grams per kilogram. Right. So, but okay, if you want the number without trying to figure it out, on average, around 45 grams a day for women and around 56 for men. But remember, it's weight based. So there we go. Man, I was on the last slide. I probably could have pulled it off without chasing for my charger. But whatever, we're at the end. Please think about proteins differently than you might have thought about them before. They serve every function pretty much in your body. All right, if you have any questions, feel free to reach out and you'll have a good day.